Hey everyone, welcome back to the Girl Has It All channel. This is our ninth deep dive into complicated stuff. And today we're looking at some really cool connections, things you might not think go together at all,
Oh, yeah.
like the Earth's rotation, the air we breathe, and even the possibility of a whole new type of particle. To help us break it all down, we've got Jenna here, our resident quantum expert from the Girl Has It All team.
Hey, everyone. Ready to get complicated?
Always. So let's start with something we all experience every day, time.
Uh-huh.
But more specifically, the length of a day right here on Earth. Have you ever stopped to think that our planet's rotation is actually slowing down?
Yeah, it's true. It's been happening gradually for billions of years. And the culprit is the moon. Its gravitational pull acts like a brake on Earth's spin.
So the moon's not just responsible for the tides, it's also messing with our days. I guess we can't blame the Earth for wanting to sleep in a little longer every now and then, but how much slower are we talking here? Are we going to need to adjust our clocks anytime soon?
Not quite. It's only milliseconds per century. But over millions and billions of years, it adds up. In fact, 1.4 billion years ago, a day on Earth was only 18 hours long.
Wow. So dinosaurs were really running around with way less daylight. Talk about needing a strong cup of coffee. But here's where things get really wild. This slowing rotation is actually linked to something pretty major. The rise of oxygen in Earth's atmosphere.
Yeah, it's fascinating how this astronomical phenomenon had such a profound impact on life. It all comes down to these tiny organisms called cyanobacteria, the original oxygen producers.
Okay, so you have a slowing Earth, and we have oxygen-producing bacteria. How do these two connect? Did the cyanobacteria just decide to step up their game as the days got longer?
It's more about opportunity. Think of it like this. If the days are shorter, cyanobacteria have less sunlight to photosynthesize and produce oxygen. As the Earth's rotation slowed down and the days got longer, these little guys had more time to do their thing.
So basically, the longer the day, the more oxygen they could pump out. That's incredible. But how did scientists actually figure this out? Did they go back in time and interview some ancient cyanobacteria?
Well, that would be amazing. But thankfully, there's a slightly less complicated way. Scientists were studying microbial mats in Lake Huron, which contain different types of bacteria, including cyanobacteria. They noticed that some bacteria were more active at different times of the day. Some were early risers, while others, well, they like to sleep in.
Wait, so there are actually cyanobacteria that prefer to hit the snooze button. I never thought I'd relate to bacteria so much.
Exactly, and it's these late riser cyanobacteria that really helped scientists connect the dots. They were only able to produce oxygen at their full potential when the days were long enough. By studying these modern microbial mats, scientists could get clues about what might have happened billions of years ago during what's called the Great Oxidation Event. That's when oxygen levels in Earth's atmosphere shot way up.
So these little sleepy bacteria were actually key players in shaping the air we breathe. That's mind-blowing. What does this tell us about the bigger picture?
I think it highlights just how interconnected everything is on our planet. The moon's gravity, the Earth's rotation, the activity of these microscopic organisms, it all came together to create the very air we breathe. It really makes you think about what other seemingly unrelated things might be secretly linked.
Absolutely. It's like the universe loves to play connect the dots on a cosmic scale. Speaking of interconnectedness, let's move on to something completely different, but equally mind-boggling. The possibility of a completely new type of particle existing in the universe. So break it down for us. What's the deal with these particles?
Okay, we're about to dive into the quantum realm. In quantum mechanics, we've traditionally categorized particles into two main groups: fermions and bosons.
Fermions,
What's-
bosons. Those sound like they're straight out of Star Trek.
Yeah.
Can you give us non-quantum physicists a simple way to understand what those actually are?
Definitely. Imagine it this way. Fermions are the building blocks of matter. They include things like electrons and quarks, the tiny particles that make up atoms. And one of their key characteristics is that they can't occupy the same quantum state. Think of it like a giant cosmic game of musical chairs, where each fermion needs its own unique seat.
Got it. So no two fermions can be in the same place at the same time doing the same thing.
Makes sense.
Makes sense. What about bosons? Are they the rule breakers in this cosmic game of musical chairs?
Kind of. Bosons are the force carriers, like photons, which make up light, and gluons, which hold atomic nuclei together. They actually like to bunch up together.
Interesting. So we have the matter-building fermions and the force-carrying bosons. Pretty neat and tidy categories, right?
Well, not so fast, enter.
Paraparticles. Paraparticles. Okay, you're going to have to explain this one. Are these like the rebels of the particle world?
You could say that. Paraparticles are theoretical particles that don't quite fit into the traditional fermion or boson categories. They kind of blur the lines. The idea's been around for a while, but new mathematical models suggest they might actually be possible in our three-dimensional universe.
Wait, are you saying there could be a whole other category of particles out there that we haven't even discovered yet? That's huge.
It is. Now, this research doesn't give us concrete proof that paraparticles exist, but it opens up a whole new avenue of exploration in particle physics.
Okay, I'm hooked. But if we've never actually seen these paraparticles, why should we care? What are the implications of this research? Why does this matter to anyone outside of a physics lab?
Well, if paraparticles do exist, it could completely revolutionize our understanding of the fundamental building blocks of the universe. It would be like discovering a new element on the periodic table. But for the most basic particles in existence, think about it, our entire understanding of physics is based on the behavior of fermions and bosons. If there's a third type of particle out there, it could change everything.
Okay, that is pretty mind-blowing. So we went from a slowing Earth to oxygen-producing bacteria to potentially undiscovered particles. This has been an amazing deep dive. But before we wrap up this first part, I have to ask, where does this research on paraparticles go from here? What are scientists looking for, and what questions are they trying to answer?
That's a great question. The next step is the tricky part, finding experimental evidence of these paraparticles. Scientists are exploring all sorts of possibilities, from searching for their signatures in high-energy particle collisions to looking for them in exotic materials here on Earth. It's a real detective story, trying to track down these elusive particles.
So it's like a cosmic scavenger hunt. What are some of the big questions scientists are hoping to answer about paraparticles?
They want to know what their properties are, how they interact with other particles, and most importantly, what role they play in the grand scheme of the universe. It's like a whole new frontier of physics is opening up before our eyes.
I love it. This is why complicated stuff is so much fun. There's always something new and exciting to discover. Who knows, maybe one day we'll be talking about the discovery of paraparticles as a major scientific breakthrough.
I wouldn't be surprised. It's amazing how quickly our understanding of the universe can change.
That's for sure. Okay, everyone, we've covered a lot of ground in this first part, but there's so much more to explore. What are your thoughts on these cosmic connections? Are you as excited about the possibility of paraparticles as we are? Let us know in the comments. And don't forget, Complicated Stuff airs live every Friday and Saturday, and the episode premieres on YouTube at 6:30 p.m. Be sure to subscribe so you don't miss out on the next part of our deep dive.
We'll be back soon.
And we're back for part 2 of our deep dive into some seriously complicated stuff.
Yeah.
Before we jump back into the world of paraparticles, I have a question that's been bugging me. What's the connection between this research on Earth's rotation and the search for these new particles? They seem like completely separate fields.
You're right, they are different areas of study, but they both highlight something really important about science, the power of challenging our assumptions and looking for unexpected connections.
So it's like both of these discoveries are forcing us to think outside the box.
Exactly. In the case of Earth's rotation, scientists had to look beyond just geology and atmospheric science. They had to consider astronomy and even microbiology to understand how the length of a day could impact our planet's evolution. It's a reminder that sometimes the answers we're looking for are hiding in the most unexpected places.
And with the search for paraparticles, We're questioning the very foundation of particle physics.
Right. For decades, we've been working with something called the Standard Model of Particle Physics, which neatly classifies all particles as either fermions or bosons. But now, scientists are pushing the boundaries of that model. They're asking, what if there's something else out there? What if our current understanding is incomplete?
I love that kind of thinking. It's like saying, hey, what if we've been looking at this all wrong? And that can lead to some truly groundbreaking discoveries.
Absolutely. And that's what makes science so exciting. It's a constantly evolving process of discovery and revision. We're always learning new things, challenging old ideas, and refining our understanding of the universe.
I love that. It reminds me of how we're always learning and growing here at Girl Has It All. But let's bring this back to our listeners for a minute. We've talked about Earth's rotation and the search for new particles, but how does this impact us in our everyday lives?
That's a great question. I think one of the biggest takeaways from all of this is that we're part of something much bigger and more complex than we often realize. The Earth's rotation, the air we breathe, the particles that make up everything we see and touch, it's all interconnected.
So it's not just about these abstract scientific concepts, it's about understanding our place in the universe, right?
Right. It's about appreciating the delicate balance and interconnectedness of our planet. And the universe as a whole.
That's a beautiful way to put it. And it makes you realize just how precious and fragile our existence is.
Absolutely. And it underscores the importance of protecting our planet and exploring the universe with a sense of wonder and responsibility.
Okay, we've covered a lot of ground today, from the Earth's slowing rotation to the mind-boggling possibility of undiscovered particles. But is there anything else about this research that really stands out to you? Any final thoughts you want to leave our listeners with before we wrap up the second part?
I think what fascinates me the most is how this research challenges us to think differently about time and scale. We're so used to thinking about things on a human time scale, days, weeks, years. But when we zoom out and consider the vastness of the universe and the billions of years of its history, we see that even seemingly insignificant changes can have a ripple effect across time and space.
It's like the butterfly effect, but on a cosmic scale.
Exactly. It's a reminder that every action, no matter how small, has the potential to ripple out and shape the world around us, and that even the tiniest organisms, like our sleepy cyanobacteria, can play a crucial role in shaping the very air we breathe.
That's a powerful thought. It makes you realize that we all have a part to play in this grand cosmic story. Okay, everyone, we're going to take a quick break, but when we come back for the third and final part of our deep dive, we're going to be talking about some of the biggest mysteries that scientists are still trying to solve. And we want to hear from you. What are your thoughts on these cosmic connections? What questions do you have? Leave a comment below, and we'll do our best to answer them in the next part.
We'll be right back.
And we're back for the final part of our cosmic deep dive here on Complicated Stuff. Before the break, we were talking about the interconnectedness of everything in the universe. It really makes you wonder, what other mysteries are out there just waiting to be uncovered?
Yeah, it really does. And even with all the amazing discoveries we've made, there are still so many questions that we haven't answered.
Like what? What are some of the biggest puzzles that scientists are still trying to crack?
Well, one of the most fundamental mysteries is the nature of dark matter and dark energy. We know they exist because of their gravitational effects on the universe, but we still don't know what they're made of. It's like there's this whole invisible universe out there that we can't see or interact with directly.
That's both fascinating And kind of spooky at the same time. Like, what if dark matter is actually made up of those paraparticles we were talking about earlier?
That's one of the possibilities that scientists are exploring. If paraparticles do exist, they could potentially interact with dark matter in ways that we haven't even imagined yet.
So these hypothetical particles could be the key to unlocking one of the biggest mysteries in physics. That's pretty incredible.
It is. And then there's the question of how life originated on Earth. We know the basic building blocks, but the exact process of how those building blocks came together to form the first living organisms is still a mystery.
And once we figure that out, could it help us understand if there's life on other planets?
Absolutely. If we can understand the conditions that led to life on Earth, we can start to look for similar conditions on other planets.
So the search for extraterrestrial life could be linked to understanding the very origins of life itself. It's amazing how everything seems to connect back to something else.
It really is, and that's one of the things I love about science. It's a constant journey of discovery.
Yeah.
And every answer leads to more questions.
It's like the universe is this giant puzzle, and we're slowly piecing it together, one discovery at a time.
Exactly. And who knows what incredible things we'll uncover in the years to come.
Well, this has been a fantastic deep dive. We've gone from the Earth's slowing rotation to the possibility of brand new particles, explored the mysteries of dark matter and the origins of life, and seen how everything is connected in this grand cosmic web. I'm definitely leaving this episode with a whole new perspective on the universe.
Me too. It's been a blast exploring all these complicated but fascinating topics with you.
And a huge thank you to all of you for joining us on this wild ride. We hope you've enjoyed this episode of Complicated Stuff and learned something new along the way.
Don't forget to let us know your thoughts and questions in the comments below. We love hearing from you.
And be sure to subscribe to the Girl Has It All channel. For more episodes of Complicated Stuff, we go live every Friday and Saturday, and the episode premieres on YouTube at 6:30 p.m.
Until next time, keep those minds curious.
See you then.